Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, in today's video, we're going to take a detailed look at pre-order tree traversal technique. Now before we proceed, if you've missed any of the previous tutorials, we've already discussed what is a tree, what is a binary tree, what is a binary search tree. We even started with the implementation of binary search tree. And then lastly, we took a look at the different tree traversal techniques. And we took the working as well as the diagrammatic examples in the previous tutorial. So if you've missed that, if you don't know what is tree traversal, please do check out the previous tutorials in this course. Now if you already know what is tree traversal and if you've seen the previous tutorial and if you have an overview of the working of pre-order, then you're good to go. In this tutorial, we're going to take a look at the pseudocode as well as we're going to write a C++ program to implement this pre-order technique. Okay. So make sure you watch this video till the end if you want to have the practical knowledge as well. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see on the screen, on the left hand side we have the pre-order pseudocode in the form of English steps. This is something that we saw in the previous tutorial as well. And at the bottom in the blue we have the pseudocode which looks like a function, part English, which essentially we will be using to convert into C++. Okay, so in order to write a program, a pseudocode is much more easier to directly convert into a code rather than proper plain English. Okay. And on the right hand side we have a binary search tree wherein we have the different nodes linked to each other. So this is the root node, the name of the node, the address in the memory that this node is created. So N1 is created in the memory address #31. Okay, so that's its memory address. Of course this memory is not real. We are just using it for understanding purpose because ultimately we want to write a program, right? So hence we are using this kind of diagram. Now in the node we have the value in the center. The value is also termed as key at times. It is also known as data. And the left part is the address which links to the left child. And the right part is the address which links to the right child. And this is common to all the different nodes. It's pretty understandable. Okay. Now this is a binary search tree, which means that it follows the principle where for a particular node, the left subtree has lesser values. So for node N1, the entire left subtree has values 18, 10 and 25, which is less than 30. And for the right subtree, which is this part, all the values are greater. So that's the basic principle of a binary search tree. I'm guessing you guys already know that. We are taking a binary search tree for our understanding and because we've begun with the implementation of binary search tree in previous tutorials, especially with the insertion. But this same technique will be applicable to a regular binary tree as well because structurally both of them are same, but the values are different when it comes to the storing. Okay. So all these tree traversal techniques that we're discussing will be applicable to a general binary tree as well as a binary search tree. Okay. So now that's out of the way. The last thing that you need to understand this tutorial thoroughly is the concept of recursion or recursive functions, because recursion is going to be used in the pseudocode in the code itself. Now if you don't know what is recursion, I have a separate dedicated video with C++ which explains the concept of recursion. If you have the basic understanding, you'll understand this video very well, but I would highly recommend if you're a beginner, just watch that video. That is very important. I'll link that in the video description or you can see a card. But now let's get to the pseudocode. Okay, so in previous tutorial, I discussed the 3 steps that are required when it comes to pre-order tree traversal. And the 3 steps correspond to the node left-right chronology. So first step is node, which says access the data part of the current node. The second step is traverse the left subtree, which corresponds to left. And the third step is traverse the right subtree by using recursion. So step 2 and step 3 are recursion. Step number 1 is to access the current node. Okay, now coming to our pseudocode, we have the same 3 steps in the form of pseudocode. However, there is one extra step, which is step number 1, which is basically the stopping condition. Because if you give a recursive call infinitely, your program will go in an infinite loop and it will crash. So when it comes to the implementation, when it comes to the practical side, of course you need to write the code in such a way that there has to be a condition where the recursion will stop, and that is this step. Now I know it might not make sense as of now, but don't worry, we're gonna run this entire PreOrder pseudocode step by step recursively with the help of diagrams, so you'll understand everything, that this condition as well as the different steps. But this is one extra step which is used to stop the recursion. Okay, so this is the function name print PreOrder, because we are gonna print all the values and we're gonna traverse in a PreOrder way. So even though this is a traversal, we are basically gonna print the values, hence the output column over here, which we will populate when we will traverse the entire BST tree. Alright, so this print PreOrder function takes a node. Okay, so that's why this is the argument. T star R basically is nothing but the address of the particular node. When I say address, it is because we are gonna write a C++ program, we are gonna deal with pointers. So that's why this syntax. And then we have the step number 2, 3 and 4, which is exactly the same as these 3 steps which are in plain English. Step number 2 is to printing the value, that is the access the data part. Step number 3 is calling print PreOrder on the left subtree, hence R of left. R would be the current node and R of left would be the left child. Step number 4 is again a recursive call to R of right, which is the right child. So these 2 steps are nothing but recursion. Okay, alright, so now that we have a basic overview, let's directly implement this function onto our existing binary search tree. So let's call print PreOrder for the first time, and we will obviously start from the root. So this is the root node. So for the first time we will pass n1. So n1 will be passed in this function, so R will be corresponding to n1. Okay, alright, so let's see the first call, that is the first function call. Okay, so this is the very first print PreOrder function call. We are passing n1. Now this is not a recursive call, because for the first time from the main function we are simply calling print PreOrder. Okay, alright, so starting from the very first line, that is the first line of code in the print PreOrder, the first line is a condition which says if R equal to null, then return. Return means just stop this function over here and return to the calling function. So in the main function we will call print PreOrder, and when we do the return we will come from print PreOrder to the main function back. That's how the function call work. But right now you can see that R is pointing to n1. So currently R is n1, and n1 is obviously not null. It is created in the memory at #31, so it is not null. So this condition becomes false, right? We are checking if R equals to null. R is not null, R is pointing to n1. So this condition becomes false, hence we move forward to step 2. Now in step 2 we say print R of value. R is currently pointing to n1. What is n1's value? That is the value stored inside n1, it is 30. So we are saying print R of value. So now 30 will be printed in the output on the command prompt when we write the C++ code. So let's write output over here. I'll write 30, and this is the very first value being printed. Okay, alright. Step 2 is done. Now we move to step 3. Now this is where step 3 is a recursive call, because you can see the name is the same, that is print PreOrder. We are giving a recursive call, but this time the node that we are passing is equal to R of left. Currently R is pointing to n1, right? Which node is there to the left of n1? This is #16. What is #16? #16 is the address of n2. You can see over here, #16 is nothing but the address of n2. So basically we are passing n2 over here in the second function call, or our first recursive call. Alright, so let's see that call. Okay, so as you can see we have a second function call, which is our very first recursive call to the same function print PreOrder, but this time we are passing n2. Now the first print PreOrder gave a call to second print PreOrder over here at step 3. So what will happen to the first print PreOrder call? Because you can see that the first print PreOrder call is at step 3, it still has to do the step 4, but because it gave a recursive call, it has to go in a pause state. So this is where the first print PreOrder function will go in a pause state. So let me do a pause symbol over here, and it is paused at step number 3, because at step number 3 it gave another call to print PreOrder, so it's a recursive call. So let me write 3 over here. So the first print PreOrder where we passed n1 is now paused at step number 3. It still has to do step number 4 because only after completing all the steps in the function will a function be completely over, right? But it got paused at step 3 because it gave a recursive call. So hence it goes in a pause state, and this first print preorder is calling second print preorder. Okay? Alright. Now when you give a second print preorder call, we are passing n2. Again, this 4 steps, that is this entire function will be started from the very first step. So let's do that. This time the r is going to be n2. Let's write n2 over here. Again, coming to step number 1, if r equal to null, then return. Is r null? No. R is currently pointing to n2 and n2 is existing in the memory. It is not null. So this step will not be true. We will not return. We will continue. We will go to step 2. We will say print r of value. Currently r is pointing to n2. What is the value inside n2? It is 18. So we want to print that. We'll write 18 over here. Okay. Step 2 done. Now we will go to step 3. But again, at step 3, you can see we are giving a recursive call to print preorder, and again we are saying r of left. R is what? N2, which means r is over here. Who's to the left of n2? It is the address #6, and #6 is the address of n4. You can see. So basically now we are giving another recursive call and we are passing n4 this time. So let's see that recursive call. So now a third function call is given from second function print preorder to third print preorder, and this time we are passing n4. And obviously since second print preorder was paused at step 3, it will go in a pause state because it still has to complete its execution. So let me do a pause sign over here, and it is paused at step 3 again. And now this third print preorder with the argument of n4 will again start from the very beginning. So I hope you are understanding how the recursion is progressing. Let's continue further and you'll understand even more. Now for the third print preorder, r is equal to n4. Again, r is not equal to null, so this step will be skipped. So step number 1 is done. Step number 2 says print r of value. Right now r is n4. n4 is a value of 10. So let's print that. I'll write 10 over here. Then we will move on to step 3. And again a print preorder call will be given. But this time if you see, r of left is nothing. R is currently pointing to n4, right? R is n4. In the n4 node, on the left and right, we don't have anything because we do not have any children. So these two values will be nothing but null. Programmatically, they will have the value of null. All the children will have the value of null. Correct? So this time r of left is nothing but null. So we are passing null and we are giving one more recursive call to print preorder. So let's see that call. So again, third print preorder gave a call to fourth print preorder, but this time we passed null in it. So of course third print preorder got paused at step 3, right? So we have to do the pause symbol. So third function got paused again at step 3. Let's write 3 over here. And we are at fourth print preorder call, wherein we have passed null. So again we will start from the scratch, that is start from the very first step for the fourth call. Now when you are passing null, this r is now become null, right? So at step number 1 we are checking if r equal to null, and this time this if condition becomes true. So we say if r equal to null, then return. And when I say return, you will completely exit from this function and go back to the function that called you. So fourth function, that is fourth print preorder, was called by third print preorder. So when I say return, the fourth function will return back. So it will complete its execution and it will return back to third print preorder. So now you can see the called function is going back to the calling function. So once you come back from fourth print preorder back to the third print preorder, this was in a pause state. Now it will go in a continue state. It was paused at step number 3. Step number 3 is done. So now we will continue this print preorder, which had the r value, or that is the tree node value as n4, and we will continue it from step number 4 because it got paused at step number 3. So first 3 steps were already done for the third print preorder. We were only left with the fourth step. So for this third print preorder with the r value of r equals to n4, we will continue with the fourth step. Now if you observe, the fourth step is nothing but another print preorder call, another recursive call, but this time we are saying r of right. So r is currently having n4, which is this node. R of right is nothing but null because we don't have a right child. So again we will give a fifth preorder call. So you can see a fifth preorder call, but this time again we will pass null in it. So from third print preorder call we are giving a fifth print preorder call, we are passing null. Okay, so again third print preorder will go in a pause state, correct? So let's write pause sign over here, but this time it is paused at step 4, that is the last step. So after this last step it will complete its execution, but first we will have to execute this fifth recursive call, that is this fifth print preorder call, and we'll have to do it from the start. Okay, so let's execute this fifth print preorder call with the argument as null. So r is nothing but null, and at the step 1 itself we check r equals to null, then return, which means that we will directly return from fifth print preorder to the calling function, which is the third one. So third print preorder you can see has called fifth. So we will go back from fifth print preorder back to third print preorder, and since this was paused, now this will resume because it has completed step 4. And once it has completed step 4, basically you are coming at the end of the function. You have only 4 steps, and this third print preorder has now completed all the 4 steps. So again this will also complete its execution and it will go back to its calling function. Who called the third print preorder? It was second print preorder. Now you can see over here the second print preorder is paused at step number 3. So when this third print preorder completes its execution, it will go back to the second print preorder with the r of n2, that is the node as n2. Alright, so now this print preorder was paused at step 3. So now it will again resume and start with step 4. It was paused over here, it will go back to step 4. So it will continue its execution, and step 4 itself is a recursive call. You can see we are saying print preorder r of right. So when you come to this print preorder, we had n2. So r was n2. What is there to the right of n2? We have hash 26. Hash 26 is nothing but the address of n5. So we're gonna pass n5 over here. So now second print preorder function is calling a sixth print preorder. So this is the sixth print preorder called by second print preorder, and this time we are passing n5, which is right child of n2. Okay, so again this second print preorder will go in a pause state, and this time it will be paused at step 4. So let's write the pause sign, and it is paused at step 4, which is the last step. So it is paused over here because it is given a recursive call. So we have to resolve this recursive call first, which is print preorder n5. Alright, so let's start the execution of this sixth print preorder. So when you start with the execution, r is nothing but n5. We are passing n5 as the argument. We check if r equal to null, then return, but r is not equal to null. R is pointing to n5. So this step will not be executed. We will go to step 2. So at step 2 we are saying print r of value. R is n5. We just said we passed n5. N5 has the value of 25, so 25 will be printed. Let's write 25 over here. So step 2 is done. Now we go to step 3. Now in step 3, you can see we are giving a recursive call to print preorder. So now we are giving another recursive call. We are saying r of left. R is nothing but n5. So this is n5. What is there to the left? We have null. What is there to the right? We have null. So let's see the 7th print preorder call. So 6th print preorder gave a call to 7th print preorder, and we've passed null in it, which means that the 6th print preorder is paused at step 3, right? So this goes in a pause state at step 3. For 7th print preorder we are passing null, which means at the very first step it is going to return and it will come back to its calling function, which is step 6, which is function 6. Now 6th print preorder will again resume its execution. It's completed step 3, so it will go to step 4. So step 4 is again print preorder r of right. So r over here is n5 and r of right is nothing but null. You can see there is nothing there to the right child of n5. So one more print preorder call is given, and we are passing null in it. So let's see that call. So you can see 8th print preorder call is given from 6th print preorder. So again it goes in a pause state. So I'll pause this function, it paused at step 4. When you pass null in the 8th print preorder, at the very first step we will return because r equals to null, and now it will come back from 8th print preorder back to 6th print preorder. 6th print preorder will resume its execution. It was paused at step 4. It will resume from over here, but there is nothing else. That is, there are no further statements inside it, which means that the 6th print preorder is done its execution. So now it will complete and go back to the calling function. Now who called 6th print preorder? You can see the blue arrow. It was called by 2nd print preorder. So it will go back to 2nd print preorder. 2nd print preorder, you can see I've written 4, which means it was paused at step number 4. So when you resume the 2nd print preorder, it has paused at the last statement. So once it is done, even this 2nd print preorder N2 will complete its execution because it was paused at step 4 and there is nothing further to it to execute. So that function is done. So it will also return back to its calling function. And who had called 2nd print preorder? It was the very first print preorder call. So you'll go back over here. When you come from 2nd print preorder to 1st print preorder, the 1st print preorder was paused at step 3, right? You can see I've written step 3 over here. So now it will resume its execution and move to step 4. So when you move to step 4, for this first print preorder function, we have the r value as n1. So r is n1. And now we are at step 4. Step 4 is print preorder r of right. R is n1. Who's there to the right of n1? You can see we have an address #99 and it is the address of n3. You can see. So basically now we are again calling a recursive call to print preorder and we are passing n3. So now a 9th print preorder will be called because this was the 8th. So 9th print preorder will be called from the first print preorder, you can see. So this is how we are calling the 9th print preorder from the first print preorder. So again, first print preorder will go in a pause state and this time it will go in a pause state at step 4, right? So let me write 4 over here and let's do a pause symbol. Now we are calling 9th print preorder. We'll have to do it from the start, correct? Let's run this 9th print preorder from the start with the r value, that is the node, as n3. Okay, so r is now n3. This is the call. Step number 1. If r equals to null, r is n3, so r is not null, so this will not be executed. Step 2, print the r value. R is n3. What is the value inside n3? It is 45. So let's print that. I'm gonna write 45 over here. So step number 2 is done. Now we move on to step 3. Alright. So step 3 is another recursive call. We say print preorder r of left. R is currently n3. What is there to the left of n3? We don't have anything. We have blank null value. So now we are gonna pass null. And now we are gonna give the 10th function call. So let's see that. So 9. That is the 9th preorder will give a recursive call to 10th print preorder and we're going to pass null. So of course when you pass null, the very first step inside this 10th recursive call is if r equals to null, then return. So we'll directly return from 10 back to 9. So 9 was paused at step 3 and it called 10. 10 executed completely and came back to 9. So now we will move to step 4 for the 9th preorder. So for the 9th preorder function, step 4 is another recursive call, but this time we are saying r of right. Who's there to the right of n3? It is #83, which is the address of n6. So now over here we are passing n6. So now a 11th function of print preorder will be called where we are passing n6. So 9th preorder gave a call to 11th print preorder with the node value of n6. So the 9th print preorder got paused at step number 4, right? Because this is where we passed the n6. That is the second recursive call. So let's do the pause symbol. 9th print preorder is paused at step number 4 and it has now called 11th print preorder n6. So let's execute 11th print preorder first. Alright, so over here r is n6 for the 11th print preorder. we will say is r equal to null? No, r is not null, r is pointing to N6. So we'll go to step 2. We will say print r of value. What is the value inside the node N6? It is 65. So let's print 65. So I'm gonna write 65 over here, and step 2 is done. Now move to step 3. Now step 3 we say print preorder r of left. R is currently N6. Who's there to the left? It is blank. Who's there to the right? It is blank. So first we'll pass null over here. We will call a 12th print preorder. So 11th print preorder gave a call to 12th print preorder with the value of null. So this is what we passed over here, null. As soon as we pass null and start executing this 12th print preorder, the very first statement in that would be r equals to null, then return. So we'll directly return from 12 to 11. So 11 was paused at step 3 in the meantime, and as soon as the 12th function returned back to 11th function, it will again start its execution and it will move to step 4. In step 4 we will give print preorder r of right. Who's there to the right of N6? We have again null. So again null will be passed, and the 13th print preorder will be called from 11th print preorder, and this time again we are passing null, and this 11th print preorder will be paused at step 4. It is going in a pause state at step 4. As soon as you call 13th print preorder and pass null in it, as soon as this starts executing, at the very first step itself we are saying r equals to null, then return. So obviously 13th print preorder will return back to its calling function, and who called 13? It was 11th print preorder, so we came back. So now this will not be paused, 11th print preorder will not be paused, it will continue its execution from step 4. It was paused at step 4, right? So after step 4 we don't have anything, which means 11th print preorder has completed its execution. It will go back to its calling function. Who called 11th print preorder? It was print preorder 9. You can see the arrow. Even 9th print preorder was paused at step 4. So when 11th print preorder will go back to 9th print preorder, it will continue its execution from step 4. So from step 4 there is nothing else to go, which means even 9th print preorder has completed its execution, which means it will go back to its calling function. Who called 9th print preorder? It was the very first print preorder call, right? You can see the arrow, blue arrow. So it will go back to the first print preorder, and first print preorder was paused at step 4. So it will resume its execution. But after step 4 there is nothing to execute, which means even this will be done with its execution. And now if you observe the output, we have basically traversed the entire tree and printed all its values in preorder format. So this is the entire preorder tree traversal technique with the use of recursion. And I hope with the use of diagrams with the arrows and the step-by-step traversal, you've got a good understanding of how the recursion progresses and how it comes back and how we get the output. Now if you use these plain simple English steps, apply it on the same binary and apply it on the same binary search tree, you'll obviously get the same output. We've discussed how you do that part. We've already discussed how to use these steps in the previous tutorial. So keep this output in mind, and now we will go to the C++ coding part. So let's jump to the practical part and convert this pseudocode into proper C++ code. Just keep this output in mind so that we can cross-check it with our C++ code, because we'll enter the same values for our binary search tree. Okay? Alright. Let's switch to our dev C++ IDE. Okay, so as you can see on the screen, we have already typed in some code. That is because this is the continuation on the binary search tree implementation code that we've started, and we've already done with the insertion. So if I scroll down in our class BST, we have the insert node code completely done, and we also had a print 2D function which was there just to print out the tree. I will explain this code later on, but right now the topic is printing the tree in the preorder way, right? So here we will create one more function, print preorder. So what I'll do is I'll directly paste the code over here and we'll go line by line. We only have like 4 instructions, so it's gonna be basic. It's just recursion, and on the right hand side you can see the pseudocode as well. So yeah, this is the only code for printing in preorder. You basically take the address of the node. The first step is if r equals to null, we say return. So that's step number 1 in the pseudocode. This is the second step where you print the value inside that node. So that's the step number 2 in the pseudocode. So we say first print the data of the node, and then this step is print preorder r of left. So this is a recursive call to the left side of the tree, and then this is the recursive call to the right side of the tree. So this is basic. If you want to type this code, just pause the screen and type this entire code. If you're a beginner, I highly recommend that you type this code at least once. I will be sharing this entire code of the entire implementation of binary search tree with you guys on our official website. So the link to the entire code will be there in the description. You can check that out. But as I mentioned, just type it out once at least. And yeah, this is the function which is there inside our class. So scrolling down into our main function, this is where we are printing it, right? So I'll just copy this and I'll paste it one more time, and I'll say obj print preorder, and again we will pass the root node because we will start printing from the root. So the traversal always starts from the root, okay? Because we have to pass one node over here and we have to pass the address basically. Alright, so let's save this, and the rest of the code I've already explained in the implementation when we started off with the implementation of binary search tree. So if you want to know what exactly we are doing, we're creating a menu driven program which takes in node values and inserts it, and this is a binary search tree implementation. So after insertion, of course, we want to see what we've inserted, right? So that's where the printing comes. So this 2D printing is for visual printing, and I'll explain that function later on. But the printing preorder is where we traverse and print in a preorder way. We want to observe the values inside print preorder. So let's save this. Let's go to execute, compile and run, and let's see if our printing works fine. Okay, so our code is running fine, which means there are no syntax errors. Now what we will do is we will use the same values that we debugged into our BST, into our digital blackboard. So I hope you remember those values. So first I'm gonna say option 1 to insert. So the first root node value was 30. I'm gonna hit enter. You can see value inserted. Now the insertion code we've already discussed in previous tutorials. So if you want to know that, you can check out this playlist and see the insertion code for binary search tree. Again we will say insert. Let's insert the left node, it is 18. Hit enter. Again value inserted to the left. Again it is saying what operation do you want to perform. We want to insert more. Hit enter. This time it is 45 for the right child. Hit enter. You can see value inserted to the right over here. And again it is asking whether what operation do you want to perform. Again we want to insert. Now we want to insert 10. So value inserted to the left. Again we want to do the insert. We want to insert 25. So value inserted to the right. Again we want to do insert. And one last thing is left is we want to insert 65. Okay, so this is the binary search tree that we just dry run our entire pseudocode on. And to see that, now we have to call the print BST value function, which is option 4. So when I hit option 4, basically what is going to happen, the print 2D function will be called, wherein the entire tree will look in a 2D way. And then our print preorder function will also be called. So we can verify the values if they are printing in proper preorder way only. So let's see, hit option 4 and hit enter. And there you go, this is our tree. It is, rotated 90 degrees in anti-clockwise direction, but that is the best representation on a command prompt. So this is the exact tree that we just saw on our digital blackboard also. But more than that, this print preorder number is what is more important. You can see the values printed as follows: 30, 18, 10, 25, 45, 65. And then of course again the menu driven program is running. So I should have had a cout endl over here, but you're getting the output which is exactly the same that we saw in our digital blackboard. So if you go back to the digital blackboard, you can see that we are getting this same output. So 30, 18, 10, 30, 18, 10, 25, 45, 65, 25, 45, 65. So this means our program is working perfectly fine, and we have successfully implemented the pre-order tree traversal technique, which is a depth first technique, that is DFS technique. Okay, so this was the entire pre-order tree traversal with the pseudocode, with the C++ program, with the full implementation, as well as the working diagram and visual representation. Okay, so I hope you've got a good idea of this tree traversal technique. If you understood this entire video, this entire technique, please give this video a like. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next one. Peace.